Topic 4 is interest rates, and this topic has one objective that I'm going to discuss in this video, and that objective is to use interest rate formulas to find unknown values. Alright, so before we begin, we have to talk about 3 formulas that I'm going to reference within this video. Alright, so the first one is simple interest, and throughout this video I'm going to mention keywords. Meaning that if you see a specific word, that will lead you to hopefully know what formula to use because of that word. The first keyword is simple. Alright, the simple interest formula, whenever you see the word simple, this would be the formula that you use. A equals P times 1 plus RT. Alright, and I'm going to explain what those variables are in just a second. Now, compound interest is a little bit different, and compound keywords for that will be down here. So monthly, weekly, daily, words like that, okay? Meaning that they compound more than once in a year. Or even the word annually means that it just compounded once, that type of thing, okay? Compound interest formula is A equals P times 1 plus R over N, all raised to the N times T. Alright? And then finally, continuous. Continuous is another keyword, so let me underline these 3 as well. Monthly, weekly, daily, words like that would be considered compound interest. And then continuous, if you ever see the word continuous or continuously, you use this formula. A equals P E to the R T. Alright, let's talk a little bit about what these variables mean. I'm going to call the future value what something will be worth, something like that. P will be the present value or initial value, but I'll write present value. R is the interest rate. Knowing that they usually give it to you as a percentage, you have to change it to a decimal. That R looks like a V. I'm going to erase that because it's bothering me. Let's go down the list. Then N is the number of times compounded. T is the time in years. And then the other one, you see the E is a number, just like pi is a number. You know, pi is an irrational number. E is a number founded by a guy named Euler. It's irrational, meaning that it's, so I'm just going to put an irrational number. .71828 and so on. The decimal goes on forever. It is used in mathematics. It is the base of the natural log, so you've heard about that a little bit in this module already. But just know that E is its own number, alright? It's not technically a variable, it's a number. So, I have described all of the letters you see in these formulas, so let's go put some of this into action. I'm going to do an example and have you try an example within this video, and then I'm going to have you try some practice problems on your own. Alright, so for the first one, the question asks, how much is 1,000 worth after 8 years with 10% simple interest? So, a couple things I want to note if I'm going to be looking at this problem is, first, what variables can I identify? So I'm going to actually list out my variables, but before I do that, I'm going to look for the keyword which tells me which formula to use. And in this case, I see the word simple interest, or just simple but simple interest. So that means I'm going to be using A equals P times 1 plus RT. So I need to identify then my A, my P, my R, and my T. Those are the only variables I need to know in this case. So I would like you to do the same. Please write down the unknown variables, and we're going to fill them in as we discover what the problem gives us. So if we read the question again, how much is 1,000 worth after 8 years? Well, 8 years, T is time in years, so I'm going to put 8 for time. That's pretty straightforward. And how much is 1,000 worth after? These words worth after mean that 1,000 is the present amount, and we want to know how much it's going to be worth after 8 years. So my present amount is 1,000, meaning that the question or the unknown we're looking for is the future amount, or A. And in this case, it gives us 10% as an interest rate. So if I write 10%, remember I need to switch that into a decimal. So remember that math, it's 10%. Decimals here, you move it twice, and it becomes 0.10. So I'm going to use 0.10, the decimal form of 10%, in my formula. And then from there, we just put the new values in for the variables. So I'm going to write A again, because we're looking for A, equals P, which is 1,000, times 1 plus R, which is 0.10. I like to put things in parentheses, especially if I'm inputting something and they're multiplying, times T, which is 8. And if I enter this, if I simplify this math, that will give me my A, my future value of what this loan, or how much $1,000 would be worth if you were even investing it into something. So let me go ahead and calculate that. So after doing the math, I get my future value to be $1,800. And I am done. That answers the question. Now, if I was going to show you how to go about 4 different other situations that occur, all this is just happening here. Now we're going to go try monthly, weekly, daily, meaning that the interest is compounded monthly, weekly, and daily, and then continuously. Okay, so those change. We're going to reference, because I see the word compounded, we're going to use this formula, and I see the word continuously, so we're going to use this formula as well. So for compounded for monthly, weekly, and daily, it's the compounded interest, and then continuously, it's the continuously interest formula. So if I'm going to do monthly, all of my other all the values that I'm going to use for my variables are still the same. My A is still going to be unknown because I'm going to start comparing, well, what happens if I invest this $1,000 and it's compounded monthly instead of just a simple interest? Will it be more or less? We're going to start looking at that. So my A is still unknown. My P is still 1,000. My R is still 0.10. T is 8. And in this case, the question I have to ask myself, what does monthly mean? Well, in reference to a year, there are 12 months. So it's going to be compounded 12 times. So again, monthly means how many times is it compounded in a year? 12, because of 12 months. Now I have all of my pieces for my formula. So I'm going to fill in the variables with their values, and I'm going to use this formula, remember. So A equals my P, 1,000. Times 1 plus 0.10 or 0.10 over n, which is 12, raised to the 12 times 8. All right, and that value, or that formula, will give me a new value of $2,218.18. So if you notice, it increases. It compounds monthly versus just simple interest. Your amount increases after the 12 or after a year. Now let's try weekly. So if you notice then, the only thing that weekly is going to change is my n. Now my n, I'm going to consider how many weeks are in a year, and there are 52. There's a bad 5. There are 52 weeks in a year. So everything else, my P is still 1,000, my R is still 0.10, my T is 8, and the only thing that's changing is my N is going to change to 52. So let's try this now. A equals 1,000 times 1 plus 0.10 over, instead of 12, I'm going to write 52, raised to the 52 times 8. If I calculate that, let's see if that changes my new future amount. It does a little bit actually, $223.83. So if you notice then, if it compounds weekly, the amount goes up by about $5, but it does increase. And if you consider why, I would say the short answer is there's more weeks in a year than months, and so it's compounding more times in a year. And to finish off my example, I'm going to work through the continuously example. So the keyword continuously, I'm going to use A equals P e to the RT. And so if you notice, I already have my A, I already have my P and my R and my T. So I don't need to identify any new variable. There's no N in this formula. So I'm going to write A equals, instead of P, it's still going to be 1,000. E raised to the interest rate of 0.10 times my T of 8. And when I put that in the calculator, I get 2,225.54. So continuously gives us the highest amount of future value, even if it's just by 20 cents or so. So those are the 4 examples. I'm going to have you do a very similar problem just to test your ability to identify values for variables and then put those values where they need to go into the formula. So go ahead and try this example on your own. Please pause the video, and then I'm going to show my work. Please check your work with mine to make sure you are comprehending this process. At this point, you should have paused the video and tried these 4 examples on your own. I have squared in my answers for all of the future values, and again I found that the continuously compounded formula gave me the highest future value. So if your answers don't look like mine, please raise your hand and I will come by and check your work. Thank you.